Bismillahirrahmanirrahim. Hello, I'm Hendri Widiyandari. Today I'm going to deliver our research on the fabrication of PVDF SiO2 nanofiber membrane as a separator of lithium-ion battery by double jet sprayer electrospinning method. The application of lithium-ion battery as batteries for high operating systems such as electric vehicle require modification of battery component. Fire is prone to occur in high operating system on batteries due to the condition that are high temperature. So, needed a battery that has good electrochemical and safety characteristics. There are two ways to produce a lithium-ion battery which have this characteristic. First, converting liquid electrolyte to solid electrolyte. And second, using separator that are stable to high temperature. The separator is a component of the lithium-ion battery between the cathode and anode. Its function is to prevent physical contact between the anode and cathode. The separator characteristics have pores that allow lithium-ion and prevent electron flow from both electrodes. The function of separator is preventing short-circuiting. A stable separator has the characteristic of uniform microstructure. This is high electrolyte absorption, robust mechanical properties, and resistance to high temperature. So, the objective of this research is to fabricate the robust characteristic PVDF SiO2 membrane as a battery lithium-ion separator by double jet electrospinning. This is the material used for PVDF SiO2 nanofiber preparation. The preparation of PVDF SiO2 nanofiber. Step 1 is preparation of the precursor by mixing dimethylbromamide and acetone in beaker, and then dissolving PVDF powder 10% by mass at 60 degrees C, stirring 8 hours until get homogeneous solution. The electrospinning consists of rotating cylinder collector, double jet sprayer, DC high voltage power supply, and PVDF solution is inserted into the syringe. The metal needle is connected to positive DC high voltage power supply. In the same way, the SiO2 colloid is inserted into another syringe. The metal needle is connected to positive DC high voltage power supply, while the grounding is connected to rotating cylinder collector. Collector as a place of formation nanofiber membrane. This is the parameter process of the electrospinning. PVDF solution electrospinning process for 2 hours, while the SiO2 was only 1 hour. The electrospinning process was simultaneous between PVDF and SiO2 colloid. PVDF solution and SiO2 colloid syringe needle is 17 cm from the metal needle to rotating cylinder collector. The collector rotation speed was fixed at 500 rpm and the DC high voltage adjusted at 17 kV. The flow rate of PVDF solution and SiO2 adjusted at 1.5 and 0.5 ml per hour respectively. The PVDF SiO2 nanofiber membrane results must be dried in the oven at 80 degrees C for 8 hours. The physicochemical characterization of PVDF SiO2 nanofiber include scanning electron microscope, porosity test, thermal shrinkage ratio test, and mechanical property test. Electrochemical property test. The charge-discharge test of coin battery was measured using battery analyzer. This is the diagram of this is the part of the coin battery. This test is to determine the capacity and cycle of the battery. Next, result and discussion. Morphology of nanofiber membrane separator. The electrospinning process influences the appearance of separator nanofiber membrane bead. The flow rate of the solution caused the emergence of bead are not constant because a small portion of PVDF solution form a gel when in contact with air and disrupt the flow of the solution because it exhibits the polymer flow. Gel polymer will push from the syringe to the collector so that beads are formed. The addition of SiO2 colloid affects the morphological change of the separator nanofiber membrane. We can see here the SiO2 is on the sideline of the fiber. Next is the thermal shrinkage ratio. This is the equation used in the calculation. This table shows that the shrinkage that occurs in PP is very significant, causing membrane damage. If this shrinkage occurs inside the battery, it will cause short circuit, a fire, and explosion. The PVDF nanofiber membrane separator thermal shrinkage is around 5.8%, and PVDF with SiO2 500 ppm is 1.4%. Depreciating that occurs in PVDF is significant so that it will remain safe despite minor disruption due to the shrinkage. This photograph shows to us the nanofiber membrane. PVDF SiO2 nanofiber with different SiO2 content and also polypropylene as for comparison. Before and after heating at 160 degrees C for 30 minutes. Next is porosity membrane separator. This is the equation to calculate the porosity, and this table shows to us that the porosity increase after SiO2 addition. Increasing the membrane separator porosity due to the morphology of SiO2 structure is a porous material, making it possible for electrolyte absorption to occur in pore of SiO2 material. Next is mechanical properties of nanofiber membrane. First, tensile strength test. The addition of SiO2 colloid was able to strengthen nanofiber membrane mechanical property because colloidal SiO2 enter the pore crevice of nanofiber, thereby reducing pore size and causing the nanofiber membrane to become tighter. This is the equation. And the second is elongation test. From this table, we can see that increased membrane elongation may be caused by an increase in the material density due to the addition of SiO2 colloidal material, so that the bond between the molecular chain increases. This is the electrochemical test result. Lithium-ion battery performance. Battery with PVDF SiO2 nanofiber membrane separator was able to work for measure for 11 charge-discharge cycle with a specific battery capacity value of around 1.81 mAh per gram. During the testing process, the lithium-ion battery charge-discharge decreased its specific capacity to only 0.53 mAh per gram or around 50%. This value is a reduction in specific capacity between cycle 1 and cycle 11. Finally, conclusion. Based on the research conducted, it was concluded that the PVDF nanofiber membrane has a structure of beaded fiber with an average size of fiber diameter of around 192 nanometer, increasing porosity up to 89%, strengthening mechanical properties and stable temperature of 160 degrees C for 30 minutes. The PVDF SiO2 nanofiber separator specific capacity is 1.18 mAh per gram with a lifetime of 11 charge-discharge cycles. Okay, the research was the author, thanks to Minister of Research, Technology and Higher Education of the Republic of Indonesia for the financial support through the research grant of penelitian dasar. This is the reference. Thank you very much.